Great. So yeah, I'm really excited to present our story of Corrour Estate today. It's not exclusively by any means a presentation about dragonflies, but it was really nice to be invited to speak as a chance to kind of showcase a site which is undertaking environmental management that could benefit dragonflies and other invertebrates. Corrour is on this incredible journey with landscape scale restoration. But in many ways, we're still representative of the opportunity for nature recovery across much of upland Scotland, including many other private land holdings, hopefully, in the coming years. Right, so firstly, though, just to introduce myself, although Jonathan's done a very good introduction there as well, but so I'm conservation manager at Corrour Estate. I've been there for just over 2 years now, but prior to that, I was a seasonal ecologist at the Benlaw's National Nature Reserve, owned by the National Trust for Scotland. I was there for about 8 years, and then I've also started a part-time PhD on mountain woodland restoration at University of Stirling. And I'm also chair of the Mountain Woodland Action Group as well. So I kind of have a confession to make here because it's probably quite clear from this slide, but I'm actually mostly a plant ecologist specializing in upland vegetation. So I don't actually have this huge background in dragonflies or other invertebrates. And so kind of before I came to Corrour, I didn't actually know too much about identifying different species. I kind of maybe knew about golden ring dragonfly, four-spotted chaser, they're very common ones, but not much else. But I kind of think it's really important to recognize that you don't have to be this complete expert to get involved with dragonfly conservation. And that's especially true when we just have this wonderful BDS on hand to help out people such as myself who are excited to get involved, but maybe don't quite know where to start. So I'm just so grateful to Danielle and Pat for engaging with Corrour and helping us set up the Azure Hawker conservation work that I'll discuss a bit later on in the talk. And such an exciting collaboration with BDS. And I'm kind of getting the impression that collaboration is quite a theme from this conference. And it kind of just goes to show that it has a huge value, even for quite a large estate such as Corrour, that we collaborate with other organisations such as BDS to really kind of achieve the best we can for habitat restoration and biodiversity. And I'm really enjoying this conference as a chance for me to learn so much more about another species group as well. So it's been a really fantastic day. So Corrour Estate is a privately owned Highland estate in Loch Arbour, just east of Fort William and the Ben Nevis range. And it's probably most famous for having Corrour Station, which is on the West Highland Railway line. It covers 23,000 hectares, although 4,000 of that is the former Forestry Commission plantation to the north of the estate. So my focus today is really on the nature recovery ongoing in the 19,000 hectares of open hill area, although the commercial forestry is still being restructured towards native woodland habitats and peatland restoration too. Corrour is a very mountainous area. About a quarter of our ground is above 600 meters. One of the most common habitat is blanket bog, but we also have wet heath, acid grassland, and actually some quite sizable areas of much rarer high altitude montane habitats as well, which is super exciting. And when the estate was bought by the current owners in 1995, it was very much this kind of traditional Highland sporting estate with very high red deer densities. So the habitats and history of Corrour are, really representative of much of upland Scotland, which has experienced centuries of habitat loss and degradation, particularly due to management for overgrazing and burning. But this also means that what we're doing at Corrour now to tackle the dual biodiversity and climate crises could therefore potentially be applied to many other Highland land holdings as well. So our environmental management at Corrour has now been realigned to centre on a long-term vision for landscape scale, ecological restoration and nature recovery, with a focus particularly on allowing natural regeneration to take the lead and flourish on this journey. So the primary method that we use for achieving this is reducing the grazing pressure by deer across the whole estate to a low enough level to hopefully allow this widespread tree regeneration and also improve the condition of other grazing sensitive habitats as well. So it's not all just about the trees, as I'll explain a bit later. There are no sheep on Corrour, so our approach is about this kind of, oh, why is my slide gone forward? I'll go back. This approach is kind of about creating this synergy between a sustainable low density deer population and woodland regeneration being done without the use of fences to provide protection from grazing. And it's important to say it's about preventing overgrazing, not grazing itself, which can be actually an important ecological process. So looking at the chart here, we had over 16 deer per square kilometres back in 2006, and the last helicopter count in 2021 put us down at 0.8 deer per square kilometre, which is really very low in the current Scottish context. You might be wondering why there's this kind of spike in 2017. Well, the counts in between the helicopter counts with the squares on the chart were estimated using population models, but they don't really account for migration. And in 2017, we thought we had a much lower density than the true count with the helicopters actually revealed. But that was really important because it gave the management this real incentive to push forward with the deer control efforts even more intensively to lead to the current count that we have now in 2021. So Corrour supports this team of 4 full-time stalkers and also seasonal gillies. And alongside the culling, we've still been able to maintain some level of sport shooting, even with the lower deer densities. But it's really important that the deer stalking staff that have actually been so instrumental in kind of leading this change in habitat restoration, and also assisting me with some of the tree work as well. And we really wouldn't be able to do what we've done at Corrour without them taking the lead. So talk is kind of about regeneration at scale. So this map kind of shows the sort of scale that we're aiming for. We had a vegetation survey done a few years ago, which mapped all the different habitat types across the estate and allowed us to produce these different polygons with habitat types that could potentially have, could potentially support woodland in the future. So this work shows that we could support over 2,000 hectares of continuous cover woodland, as indicated by the dark green blocks. And it's been estimated that this could actually potentially sequester 500,000 tons of carbon dioxide over a 100-year period. But actually what is really exciting is with the potential for sort of other kind of discontinuous and scattered woodland habitats. So more in keeping with this kind of mosaic of different habitats across the open hill landscape. And I mean, that is just astonishing. It's nearly 9,000 hectares there that we could achieve of trees amongst the kind of other wetter areas such as blanket bog habitats as well. And then higher up the hill, we have potential to support some montane scrub habitat, which is really exciting. And I'll come back to that in just a minute. But are these efforts working? Are we seeing results on the ground? So I think pictures really speak for that. And these are some various pictures taken last year of trees regenerating on the open hill at sort of various altitudes. So they're obviously things were a bit quicker down at the lower altitudes, but you can see these mature trees, and particularly in the top right photo there, and then sort of scattering of smaller green clumps all over the hillside there. And then even at the higher altitudes, so the picture on the bottom left, if you were looking at this hillside from quite a distance, you might just immediately kind of write it off and think, oh, it's just barren, it's just grassland, there's nothing there. But then when I was actually walking up here, it was just incredible. It was like walking through this kind of miniature knee-high forest of birch trees that were just popping up in huge abundance. So you kind of had to get right in amongst it to see what's happening. But hopefully things will accelerate in the years to come. So these species that we're seeing regenerating, it's mostly birch and rowan and willow as well. And we've got open hill transects that show densities of 600 stems per hectare. But in some of the plots and lower altitude sites now, we routinely have over 2,000 stems per hectare, and even values in excess of 20,000 are now being recorded, which is really, really exciting. But it's not all about the trees, and if you control or reduce overgrazing, then you'll also see other grazing sensitive plants returning as well. And one of my other favorite habitat types is the tall herb habitat. These lovely luscious flowers, which are very palatable, and they are now coming down off the cliff ledges where they've been restricted to by grazing, and popping up all over the open hill with these just beautiful blooms, particularly melancholy thistle and globe flower, which are really important for the invertebrate life as well. So it's really exciting to see these, and I sometimes think these might respond a bit quicker than the trees, which are sometimes more slower growing, particularly in high altitude areas. So if we're seeing tall herbs popping up, that's a good sign that the grazing levels have been reduced. They so often get asked why we're taking this kind of natural regeneration approach rather than doing lots of tree planting. And it might be really, you might want to just get in there and get trees in the ground. It'd be very tempting to do that. But natural regeneration, although it can sometimes be a bit slower to see results on the ground, it's definitely worth it if you've got the chance to allow these natural processes to take the lead. And there's many advantages to that. And well, it's very efficient because you just basically let nature do the work itself. And because you're getting the regeneration from the outset, then that's fostering these kind of sustainable populations that are then viable in the long term. And you also get a much more heterogeneity in the landscape. So things are dotted about a bit more randomly rather than, say, people planting them a bit stricter, or people deciding where to plant trees. And then you'll also end up with trees of different age classes all kind of mixed amongst each other and different species. And then also preserves the kind of genetic diversity of the local population. And it's been shown that there's improved carbon sequestration benefits as well, to allowing nature taking the lead rather than sort of more active intervention through tree planting. But of course, there are very strong requirements to have a local seed source already present on your site for this to occur. So if you don't have a seed source, then you really have no option but to undertake planting. And also, in our case, landscape scale grazing management, if you're going to try and encourage natural regeneration without fencing. So I think it's really important to give kind of one example of where we've used this more sort of blended approach and actually had to do much more active intervention rather than just letting nature get on with it itself when we're doing the deer reduction. And this is a case for mountain woodland or montane scrub, which I'm obviously quite excited about because it's the topic of my PhD. But these montane willows, these are two specialist Arctic alpine species, and they've been restricted to inaccessible cliff ledges out of the reach of grazing animals. And we've got about 130 of these plants across the whole of Corrour. So that's not that many given the scale of the site. And so it's not ever going to produce any meaningful scale of regeneration in any speed whatsoever. So if we want to see the return of these montane scrub habitats, then we have to intervene and actually carry out some tree planting work, which can be really exciting and hugely effective. So I kind of see it as my role is to sort of prioritize these habitats and species most in need of our help. And this work of restoring mountain woodland habitats, montane scrub, is very, very challenging for so many reasons. It involves collecting seed and cuttings from existing populations, which is like restricted to these ledges and really, really difficult to get to. And then in collaboration for Trees for Life, we've been growing on these cuttings, which takes a couple of years. And then the cuttings that we've collected from the montane willows last year and this year, in a few years' time, rather than plant them just back out on the hill, we'll keep them and put them together in a seed orchard down at a low level where they can be easily accessed. And then the trees will just reproduce together and produce loads and loads of seed. And then we'll be able to use that to upscale planting in a few years' time by planting the offspring of the cuttings back out on the hill. And all of this needs to be underpinned by our deer management to maintain low enough browsing to do it all without fencing. And this work has huge benefits, which I've discussed in a review article published last year. An important component of course, biodiversity. Unfortunately, montane scrub's not known for its dragonfly life, although it does support a lot of other rare invertebrates, particularly butterflies and moths, but also willow galling sawflies, which are host specific. So there's some species that will only be found on these particular rare montane willow species in Scotland. And then that in turn supports animals and birds further up the food chain. But mountain woodland also has many other sort of ecosystem services or nature-based solutions, such as protecting steep slopes from soil erosion and damage due to landslides and rockfalls. They also slow down the water flow through upland catchments, reducing downstream flood risks. And given the extreme weather events that are becoming more common due to climate change, restoring mountain woodland will be hugely valuable for providing nature-based solutions to mitigate the impacts of climate change, such as increased rainfall, increased flooding and erosion, etc. But it is definitely not all about the trees at Corrour, even though I've just talked quite a lot about them. But I think it's really important to move on now and talk about peatlands, because I said at the beginning of the talk, it's actually the habitat that covers the largest area of Corrour. And we have a huge task on our hand to carry out peatland restoration across Corrour. So peatland restoration is really important because these habitats have been degraded over a long period of time, really not directly due to grazing, but because of trampling by animals on the ground. Also, there's been a lot of drainage of peatlands across Scotland, and burning as well has its impacts. And then even when you remove these pressures, so like we have at Corrour, reduced grazing pressures, that alone is not usually enough to restore the peatlands, because things have got so bad that then the kind of climatic effects like wind and rainfall take over, and then the erosion will just accelerate with the peat getting washed off down through the catchment, and then you end up with these big hags, and you need to actively intervene then to restore these habitats, which is of course really important for abating the huge emissions of carbon dioxide that you can have from degraded peatlands and restoring their really, really vital function in sequestering carbon. So peatland restoration involves bringing in the diggers on site and reprofiling the eroded bare peat hags, damming to slow down the water flow, and also preventing further gully erosion. So there's some photos of our sort of before and after some of the peatland restoration that we've been working on, well, started last year with a sort of new multi-year peatland action funded project across 400 hectares, I think. So this is one photo before the work took place, and then this is an after photo. So all the bare areas of peat have been reprofiled, and then there's some re-wetting there in the center. And then again, this is another before photo. So there's a sort of quite bad peat hag there. And then this is the site afterwards, and this is like literally just after. So you'd think it might look quite raw because the plant operators have just been in and worked on it, but the quality of the work is just incredible. That it already looks like this literally as soon as the work's finished. So we're really, really excited by this, but we have a huge task on our hands to sort of work on 9,000 hectares or so of peatlands that need restoring across the estate. So yeah, here is a picture of the areas that we've already undertaken peatland restoration in yellow, and we've had feasibility study complete on the areas in green of about 800 hectares there. So that's kind of waiting restoration in the next few years, and then all the brown is the work still to be done. So this is going to keep me busy for quite a long time, but it's really, really important in the context of climate change mitigation that we get on and do this. But then this is here where we also have these huge opportunities for dragonfly conservation. So I was really, really excited when I started at Corrour, that not long after I started, to be put in touch with Danielle and Pat, who had previously been to Corrour to carry out dragonfly surveys, particularly for the Azure Hawker, which is, as you know, very, very rare in Scotland. And I was so excited to discover that Corrour is this really, really important population of this rare dragonfly species. And so they had come out before I joined Corrour and done this incredible survey, which showed just the scale of the population. But then when they came back and there was a survey done the following year, it had been a year of really bad drought. And I think the figure that Danielle said in her presentation was 90% of the habitat had dried up in Scotland in recent years. And so this is this concern for us that we have this really large and key population of Azure Hawker at Corrour. But not only is there concern for the dragonfly itself, but it's also the bigger picture that if our peatland habitats are drying out, it's bad news for their ability to sequester carbon and could cause more habitat loss. So we can kind of use the Azure Hawker as this exciting indicator or flagship species for peatland health. And it was kind of an absolute no-brainer for us at Corrour that we should do something to help the dragonflies, because in doing so, we'd also be helping our peatlands. So as a plant ecologist, I'm often kind of taking this sort of bottom-up approach as focusing on plants and vegetation in my restoration work, and then hoping that animals higher up the food chain will benefit. So it's actually really nice to kind of have a go at doing a more kind of top-down approach and focusing on a kind of indicator species such as the Azure Hawker, and then if we could, which is hopefully something we can monitor in the years to come. So with advice from Danielle and Pat, we discussed this project for doing some conservation bog pools for Azure Hawker. And although we've been carrying out a lot of peatland restoration work at Corrour, none of this to date has been near the resident population of Azure Hawker. So we didn't think there would necessarily be any chance of them colonising the new bog pools and the restoration sites, at least very quickly. And we needed to do something quickly. So that's why we've kind of done this bespoke project specifically at the locations where the Azure Hawker has been recorded. And it was really exciting getting advice from Danielle and Pat about this sort of opportunity to dig some slightly deeper pools near to the existing pools, which hopefully if they were deep enough, would have these kind of refuge areas. So even if the water dries out in the summer, that hopefully there will still be some remaining in the deeper areas that the dragonflies can remain in, even when things get pretty bad with low rainfall in the summer. So we had a few days last month trialing bog pool creation. I think we created about 14 bog pools so far, spread across 2 different sites. Kind of a few different techniques. So some of it involved, very similar to peatland restoration, actually sort of damming areas where the water was flowing out of, and then the dams would get covered by vegetation so the bare peat's not exposed. And then also digging pools as well, actively digging down into the peat. And actually the digger driver could use the peat that he'd removed from the pools when he was digging to make these peat dams. So everything kind of got recycled on site. And so this shows one pool in development, and the bottom left is the same pool 24 hours later. So already filled up with water. It just shows the amazing water holding capacity of peatlands. And then the bottom right is actually last week. I came back a month after the pool was created, and it just looks incredible. So I'm really pleased. And there's just a few more photos to show of pools being dug in other places. So again, this one was an area of kind of bare peat anyway. So we are removing that bare peat and replacing it with this lovely new wetland. And it's just incredible how quickly this filled up. I wasn't sure if there would be much bare peat left, but it was great that any fears that I had about that were kind of completely unfounded. And this pool, again, this one was one that we just dug straight down without any water actively flowing into it. So when we left it, it was just this big hole. And then we came back 24 hours later, it filled with water. And a month later, it just looks fantastic. So waiting to be colonized by Azure Hawkers and other invertebrates. And these are some pools from the other site further away from Corrour Station, again, just digging down or making use of existing features. And they've all filled in lovely. So I'll be monitoring them. I'll be visiting them out through the summer. And if they get a period of very dry weather, I think I'll make a point of coming back then so I can see them potentially when they'll be at their driest, and we'll get an indication of how well they can hold water. So just to finish off, going back to kind of the bigger picture of the environmental management that we do at Corrour, and this is a way of us making sure that our nature recovery efforts are working. And everything that we do is underpinned and informed by long-term environmental monitoring. And using these monitoring data, we've developed a sort of set of ecosystem health indicators as an outcome-focused method of tracking progress over time against our aspirations and targets for the future. And the ecosystem health indicators are divided up into these 5 different categories. And the map on the right is just kind of crazy. It's so messy, but that's kind of the point, because it's just all of the EHI monitoring sites plotted across Corrour, and just shows the scale of data that we have to work with. And then from these data, I've created this dashboard, which gets updated annually. This is showing the first 2 ecosystem health indicator categories, woodland regeneration in green, peatland and other non-woodland habitats in pink. And the charts show change over time against baselines and then towards future targets. And it's just a really effective way of putting all of the data together in one place, supported by infographics, rather than everybody having to wade through reports and spreadsheets to understand what's going on. And one of the categories is indicator species, so it might be really exciting if we can maybe put the Azure Hawker or other dragonfly species on there as well. And of course, one of the categories of ecosystem health indicators specifically is on freshwater monitoring. So we do have for other freshwater monitoring across Corrour, particularly in Corrour Forest. So that's been primarily involving kick sampling across various burns, which has shown really good data in terms of water quality over the years in response to peatland restoration in Corrour Forest. and removal of some of the non-native conifer plantations. And last year I also did a trial of eDNA as sampling as well, which was just incredible because I got 600 different taxa from 10 litres of water collected across the streams. It was almost too much data than I knew what to do with. And so this wealth of data then kind of leads into a huge potential for scientific research. And we have various projects already ongoing at Corrour. So actually, the first is my own PhD project on mountain woodland restoration, which is a really exciting opportunity to kind of actually put into practice the outputs that I'm learning from my PhD on the ground, as on-the-ground action. We've also got scientists from St Andrews University doing dendrochronology, looking at dating some of our bog pines. We have advertised for another forestry PhD with University of Stirling, looking at multifunctional forestry, hoping to start in October this year. The applications close on the 30th of April, so it's still open if anyone's interested or knows anyone who might be interested in a woodland PhD. But the final slide here is about potential for more research, and top of my list, I have a long list of potential research projects, but top of my list, and this is genuinely true, it's not just because I'm talking to BDS, this is genuinely true, top of my list would be a PhD project on dragonfly conservation and invertebrate conservation. So using the bog pools that we've created to study colonization over time, and then also looking at colonization in the bog pools and the various different peatland restoration sites that we've had ongoing at Corrour as well. So I would be, I'm really, really excited to hopefully develop something like that in the coming years, because I think it's a real priority to sort of maximize the research potential from the conservation project that we've been doing with BDS. So watch this space. So that's all from me. I hope you've enjoyed listening to what we're doing at Corrour, and I just want to say thank you very much again for inviting me along and for inspiring us at Corrour to get involved with dragonfly conservation.